Yeah, please feel free.
So I have a doubt in error matrix. It was taught in the eighth lecture.
One,
The
two,
slide
three,
timing
four,
was
five.
6 minutes 57 seconds.
Okay, so in accuracy assessment and digital change detection, right?
Yes, sir.
Okay. So it was taught at which time? Can you please tell again? Can you please tell the time again? Can you hear me? Who asked the question, please? Hello, hello.
Sir, you are not audible properly due to some technical issues.
Yeah, there is a little bit of network issue today, so that may be the reason. Okay. Anyways, can you tell me who asked the question? Please, can I get the name of that person?
Sir, Sonakshi.
Sonakshi, you there? Sonakshi, can you hear me? Your mic is yeah. Sonakshi
Sir,
is
she left the meeting. She left the meeting, sir.
okay. So is
Sorry,
anyone
sir, I had some network issue.
okay? Sonakshi, yeah, at which time are you having problem? Can you please tell me?
So 6 minutes 57 seconds.
6 minute 57 second. Okay, yeah, fine. Okay. So you are having problem at this portion,
Yes,
right?
yes, sir.
Okay. Okay. How you can see the screen right now? Yeah. So this is our error matrix. Okay. First, I would like to ask you, Sonakshi, can you tell me why do we use this error matrix? Do you have any idea why we use this error matrix?
So it is used to assess the accuracy of an image or to compare between sample area on the map.
Yeah, absolutely, absolutely. So see, there are two kind of classes. One is the ground truth class, another one is the thematic map class. Okay. So what are these blocks? These are those blocks which perfectly match with the ground truth class and the thematic map class. So what are they? So ground truth class is, suppose you told that you have a region, and suppose you told that this region which you have, this region, it consists of this point as forest. This is what you said in your map, and you visited physically to this region. Physically you visited, and then you can find two things. One is that this is a forest, you can observe it. So when you are going physically and getting the information, that is known as ground truth. And when you are defining it in some other way, that is thematic. So it can be by prediction, by manual interpretation. You can give a predicted or thematic map, and similarly by visiting you can get a ground truth map. Now there can be two things. One is that this is forest and your ground truth also came out as forest. It's a fantastic thing. So both of them are forest. It can work in this way. So if both of them are forest, then this is true, right? So when you will be writing that, so suppose you have forest, you have water, you have urban. Suppose these are the three classes that you have. So you will be doing the ground truth for them, and also in thematic you can have these three only, because you will be doing ground truth of that which is present in your map. So if it is forest, this is also forest, then you will put in this box. But suppose in one case you went and you found out that instead of forest, this was actually not a forest, this was water. Then you will put that in water. So in ground truth you found out water, but in thematic it was measured at forest. So you will put it in this case. That means it will go here, this will go here. So in this way, suppose there is total 4 cross 4 16 points, and out of which you are putting how many number complies and how many doesn't comply in their respective boxes. Similarly, if you look at this condition, there are total 136 points, and after ground truthing, this is the matrix which is found. Yeah, I actually don't know why it is happening, because today the network issue is a big factor. Please let me know. I'll try to cover as much as slowly and clearly as possible. So please let me know if you are having network issues, and thank you, Mahfuz, for letting me know. Yeah, Monish, please can you tell me? Okay, have not got any assignment update. Last time I emailed you, but you don't get the response. Yeah, I mailed that back to the authorities. They have not responded, so I cannot say anything if they do not respond. You have to wait for that. Okay, is it clear? I hope it is clear. Yeah, so I was with Sonakshi. So this is that class. Now, how do we do the numerical? So if we look at the numerical, it said that sum over xkk, and here it is said sum over xk plus and x plus k. Okay, xk plus and x plus k. First, let us understand what is xkk. So xkk are, see, this is 35, this is 30, so same, right? So when we look at same thing, then we find that there are same mappings. So the ones which are circled here, so this one and this one, the three circles, they fall under xkk. Okay, and the rest falls under xk plus and x plus k. What is n square? N square is the total number, that is 136. So square of 136, and similarly sum over xk plus and x plus k is the sum of the other product of the others. So let us see what he has done after that. Just wait. Yeah, see, he has just explained the same thing. So he has said there are these classes. Now if you are looking at 35, then he's talking about, so here he's talking about xkk only. So 35, 37 and 41, these are xkk only. So for C, xkk is 30, for A, xkk is 35. Can you tell me what is xkk for B? Sonakshi, I hope it is Sonakshi's doubt. Sir, could I know since when the classes are being, yeah, first let me complete it. I'll come to you. I'll complete rest of the doubts after I complete the Sonakshi's problem. Yeah, Sonakshi, can you please tell me what is xkk for B? Sonakshi, can you tell me what is
37, 37,
37? Good. What is xkk for C?
41.
41. Absolutely fantastic. So, what we are doing is we first want to find out user accuracy. Now, user accuracy, how do we find out? So see, if we want to find out user accuracy, we have to go one by one. So if we want to find out user accuracy, then we have to take any one class first. Okay. So how do we take it? Suppose we want to work with class B, and we are interested in finding out user accuracy of that class. Now let us look at class B. So this is our class B. For user accuracy, what we will do, we will take it along the horizontal marking. Okay, and same thing, if we have to look for producer accuracy, we will take it along the vertical marking. Okay, so first we are doing user accuracy. So see, the total number, if we add it, the total number is 50, right? And xkk here is 37, right? So user accuracy will be xkk divided by the total number 50. I hope it is clear.
Yes, sir.
Okay. Now you can see that it is given as 74%. So if the accuracy is 74, the error of commission is 100 minus 74. That is 26%. Is that clear? Similarly,
Yes,
if
sir.
we look at producer accuracy, then we find out that the total number is 40 and 37 is the xkk. So for producer accuracy, we can write simply xkk by the total number of ground truth producer pixels, that is 40. Okay, just wait 1 second.
Yes, sir.
Okay, so we found out these things. Now he's telling, then what he's telling, see, so then we found out this thing. Now he's talking about overall accuracy. It is not written here, but if we look at overall accuracy, now what is overall accuracy? Overall accuracy is sum of all xkk divided by n. Okay, now if you multiply by 100, it gives overall accuracy percentage. So this user accuracy, producer accuracy are usually expressed in terms of percentage. Okay, now if you do sum of all xkk, so what are you having? You are having 35, 37 and 41, right? So you sum them all. This is the sum symbol. If anyone does not know, this is the sum symbol. So what it will do, we will take one by one and we will sum them. So then we will have 35, 37, 41. So 35, 37, 41. Sum of that divided by total number, which is 136 into 100. I hope it is clear, right? Is there any confusion?
Yes,
Please
sir.
please let me know if there is any confusion. Please let me know. Okay, acha. Next round of doubts. Anyone? Okay. What's the last date for filling exam form? Yeah, Munish, I forwarded the mail. I got 2 3 mails. I forwarded all of them to the authorities. Uh, Please wait. They are a very busy person. They'll reply as soon as possible. Okay. Uh, Tanuja, exam forms. How to apply for exam forms? Yeah, same reply to you also. Okay, Raj Tiwari. Sir, could I know since when the classes are being happening? Classes are happening for the last 4 weeks. Today is the fourth week of the class, and right now we discussed a doubt from section 8 of the first module. So I hope that clears it. Uh, oh, thank you, Raj. Yeah, please, anyone else with your doubts? I'll be happy to help you.
Sir, I have one more doubt.
Yeah, sure.
Sir, it is in the PDF, the practice question PDF. Actually, we are provided with some practice questions
Okay.
in the form of PDF just after the eighth lecture.
After
In the
the
first
8.
part,
Okay.
just after the eighth lecture.
Just after the 8th lecture.
Yes,
RS
sir.
interpretation self practice by participants, right?
Yes, sir. Yeah, that one.
Yeah, so we find out that there are a lot of questions. Okay,
Yes,
fantastic.
sir.
Yeah.
I have practiced the first two, and in the third exercise, I have doubt. Actually, I'm not getting the question how to do it or how to solve it.
Okay, so you have this third question, right?
Yes, sir.
Okay. So they are saying that the aim of this exercise is to gain awareness about. Okay, let me. Yeah. Okay, the aim of this exercise is to gain awareness about fundamental aspects of reflected radiation and spectral response patterns for different features, example vegetation, soil, and water. Okay, the aim is to familiarize with bands that maximize class separability visually. Okay, material imagery in defined bands of Landsat 8 operational lander image. Procedure given here is the wavelength corresponding to defined bands. Okay, yeah. So in principle, the higher reflectance contrast between two objects, the easier it is to distinguish between them. Study the imagery and note the following features in defined bands and perform the following steps. Okay. Identify the following features like sand, water, dry river, settlement, agriculture, forest in all the bands. Okay. Okay. See, you have been given some bands. Can you see? These are the bands that actually you are given. Just wait 1 second. Yeah, can you see? These are various images, right?
Yes, sir.
Okay, so it is mentioned, a few things are mentioned here. Let me open it. Just wait. Yeah, few things are mentioned here. What is saying that first, these are the images of Landsat 8. Okay, and these are few bands that express which band is good for visualizing what. Okay, I have been given the bands band 1, band 2, band 3, band 4, band 5, band 6, band 7. Okay, so I have been given 7 bands. So I have band 1, band 2, band 3, band 4, band 5, band 6, band 7. Now, what I need to find? They are asking me to find water, okay, sand or dry river, settlement, agriculture, forest. And they have also given us a composite band, which is FCC or TCC band. So this is our composite band. So composite 1, and we have our composite 2. This is the true color composite. We call it as true color composite. We call this one as FCC, which stands for false color composite. So we have two different things. One is a true color composite, another one is a false color composite. Now they are asking that let us identify this thing from all the bands. So I will do only one and I'll explain it to you. So let me do only the first one, water. Now I have to define it in the tone. So very light, light, medium, dark, very dark. So let us go to band 1. We are only trying to delineate water. Okay. So can you tell me which one is water? Let me do some markings and you tell me based on that. So is it water? Is it water?
No, sir.
No. Okay. So is it water?
No.
No. So is water anywhere here?
Yes, sir.
But if we look at something like this here at the bottom, don't you think that we will be getting water in a better way? Like this white portion and the small black inside the white, which one is the actual water? Yeah, feel free to tell.
Sorry, sir, I didn't get the question.
The question is, we have two portions. If we look it closely, if we look for water, so we find out that water may be somewhere inside this white channel, right? The entire white channel is not water. This is the entire thing is not river. Black portion is water, white is snow maybe. No, white is not snow. White are actually the rocks and pebbles that is present beside water. They are mostly part of the river bed, which where we don't have water, which has dried up, and the streams which are flowing in between that, the black portions, they are water. Okay. So
Yes, sir.
if we look very carefully, we can say that we have water here, and that water is expressed in dark channel, right? So how much dark? They are very dark. So if you look at band 1, they are very dark, VD. So we can write it as VD. I hope it is clear. So
Yes, sir.
we are writing it as VD. Let us go to band 2. Sir, if I want to access live data of ISRO such as INSAT or okay, yeah, but please let me complete the doubt. I'll come to you later on. Okay, Aditya Singh. Yeah. So this was the first image. Now if we go at the second image, see, in the second image too, the water is very dark, and that is also inside of it. So let me write here directly. I'm only writing for water, it is very dark. If I look here, I find out similarly here also it is very dark. Can you tell me which is better, this image or this image for identifying water? Can you tell me which image is better? This image is better or the above, this one is better for identifying water? If you
So
have
third image.
third image, no. See, if you look clearly, band 4 has better way of uh, showing water. If I just close it, look at this portion. Okay, look at this portion here,
Yes, sir.
and if you look at this portion here, so from this one is better. Okay, more channels can be seen. So yeah, here also it is in very dark, but better compared to the first case. Okay, can you tell me which one is more better now, band 5 or band 4?
So five.
Yeah, band 5, because here you are not seeing any other thing. You are seeing specially the water. Only water is shown, only the water channels are shown, no delineation, nothing. So if you go at the band structure of band 5, so it falls under near infrared region. Okay, so what is it good for? Emphasizing biomass content and shorelines, and it is able to detect water channels in the best way. So this is best for detecting the water channel till now, best till now for water, and we found out that the water is marked in very dark, and see other places where there were water, see it is also extremely clear. Okay, it is also extremely clear. Yeah, so here also water is in very dark, but water is not that clear, but compared to the other cases this is clearer. Here we can call as dark. So instead of writing very dark here, because this is very dark actually, this one is also very dark, let us write it as dark, not very dark. Okay, let us write it as dark. Let us also write this one as dark, and let us also write this one as dark, because we should not call it as very dark. They are dark. Dark is most appropriate because other portions of it are not that much. This one is not dark also, this one is less than dark, so we can call it as medium. This one is medium, this one let us call it as dark compared to the others. This one also let us call as dark, dark, very dark, very dark, dark. Yeah, and in FCC, see, we can also understand that deep blue, deep blue represents the water channel, so we can call it as deep blue, deep blue. Okay, since there is no single shade, so we cannot just write it as very dark, dark or medium, and in FCC we cannot understand, FCC unclear. From here we cannot understand. So we if we have to take any composite image, then we would rather go with false color composite, not the true color composite. So yeah, so based on that we can write here the things as if I remember correctly, this is medium, dark, 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 very dark, and dark. And color on FCC, that is false color composite. This is uh, dark blue. This is dark blue. So yeah, this was Sonakshi's doubt. Sonakshi, I hope it is clear.
Yes, sir.
Okay,
Thank you, sir.
okay, okay. So now I'll come one by one. Aditya, sir, if I want to access live data of ISRO such as INSAT and Megha topics, okay, for real-time weather and climate data in PP Suomi VIRS for air pollution, okay. So this is on the high resolution GIS and okay, what is the procedure to get it? Live data of weather can be fetched if you have weather stations, but the data that you are mentioning, I don't know how you're going to get that. We also don't get live data. We get data through our institute, so they knows the process. We are not into this process. Okay, Tanuja, how to access this practical PDF? Yeah, it's given there. It's given. It's already given in the module one after the eighth video, I think. Pashin, band 4 has more contrast. Band 4 has more contrast. Okay. Where is. Okay, contrast is a different thing, anyways. Yeah, band 4 has more contrast. We should not call it as contrast because contrast we consider for image modifications. So it's not one image that we are modifying. Band 4 has come in this way only, we can say, in which it has, we can say, more difference between the darker and whiter shades, which we should not call it as more contrast because technically this word is not correct. But yeah, if you say that if I take a image like band 1 and if I enhance the image, then we can closely get a image near about band 4 which will have better contrast. So there has to be a different way of putting the words. But yeah, I got your idea. Your idea is perfectly fine and it goes with the logic. Yeah, so I hope it is clear. And Sonakshi, you have to complete the other portions also, and this is how you should do it. Okay.
Okay, sir.
Yeah. Any more doubts, please? Any more doubts? I will be here to solve your doubts only. So if you don't ask doubts, then I actually have nothing to do. So yeah, if data is restricted, okay, just wait 1 second. If data is restricted, ISRO will provide through any college. Aditya, I cannot answer that right now. I cannot answer that right now because I don't know the process that works at the back of it. So I cannot help you. But yeah, you can get data which are not live data. You can get them through Bhuvan portal, which has recently transformed to Bhunidhi. So earlier it was Bhuvan. Bhuvan is also active right now. You can also get data through Bhunidhi. And I request all of you to confine to the lectures that has been taught because I'm not authorized to say anything out of the lectures. So yeah, any doubt within the lectures that has been taught for the first 8 lectures as was discussed last day?
Hello, sir. I have doubt in
Yeah,
the
Shiyanda, please.
lecture number 6, image enhancement.
Yeah, lecture number
Uh,
6. Okay, just wait for 1 second. Okay, lecture number 6. 1, 2, 3, 4, 5, 6. Image enhancement. Yeah. Can you please tell me the timestamp?
Timestamp is 50 minute 26 second. Concept of ratios.
2 minute 26 second. Okay. Yeah.
50 minutes 26 second.
50 minutes 26
Yeah.
seconds. Okay. Yeah. 50 minutes 26 second. Yeah, somewhere here.
Ratios concept.
Reasons and applications. Yeah, where is the problem actually? Can you please tell me?
Uh, how these ratios are calculated, as you can see, sunlit shadow or mentioned for band A and band B. So that I have doubt.
Okay, okay, okay. Okay, fine. So you are having doubt that how these ratios are calculated, right?
Yes.
Okay. So suppose I have this image. Okay, I have this image, and this image consists of two bands. Okay, this image consists of two bands, and to make it easy, let us say the first band is band A, the second band is band B. Now if we look at the diagram that has been given, the chart that has been given here, we find out that let the DN value at a pixel position is 48 and the DN value at the same position pixel for band B is 50. So this one is 48, this one is 50, right? Now they are telling that let us ratio it. So what is ratioing? We are doing 48 by 50. Now if I use a simple calculator and ratio this thing, what do we get? 48 divided by 50, that will be, sorry, 40, yeah, 48 divided by 50, that will be 0.96. So we get it as 0.96. See, this is our ratio. Okay, so this is known as band ratioing. So in this way we do the ratios. Is it clear?
Yes, it's okay.
Okay, any more doubt, please? Any more doubt, please? Okay, I would like to ask anyone. So, can you tell me why do we do band ratioing? This was the doubt of Nishiganda. Nishiganda, can you tell me why do we do band ratioing? What is the benefit of doing band ratioing?
Um, to reduce the effect of environment on the image, like if due to brightness or image was taken and due to sunlight there is more brightness on the image, so to reduce such kind of effects we can take ratios and
Yeah.
do
So
enhancement.
yeah, that's absolutely correct. That's absolutely correct. So see what is being done here. If we look carefully, that this is a coniferous tree. Okay. So coniferous tree will have some level of DN number, but the same tree, when it is viewed in sunlight and in shadow, we get completely different numbers. And for the deciduous also, they should have been same if it would have been taken in a normal condition. But if we look at it, when it is taken in a sunlit condition and a shadow condition, we find out that there is a huge disparity. There is a huge disparity between them, right? Now how do we solve this problem? So if we look at it from a satellite image, we will find out that because they will be having different DN values, they will not look same and they will not be clearly identifiable. So how do we identify these things? So one of the ways of doing it is doing a band rationing. So what happens in a band rationing? So if we simply, in any condition, just simply make a ratio of it, we get a value. And whether it is in a sunlit condition or in a shadow condition, as we get a value after ratioing, and see this value is extremely close to each other, 0.96, 0.95. They are not having disparity like this one, 15 and 19 or 48 and 18. They are not having any disparity like this. So band rationing removes the problem that one faces due to improper external conditions. So a region in sunlight and the region not in sunlight, okay, both of them will be having same dn value as per the stretching of the ratios. So that's a fantastic idea of doing these things. And yeah, so if you look at this portion, see this forest is in the sunlit side, this forest is not in the sunlit side. So a satellite image will give different values for both of them, but a band ratioed image will give same value for both of them. This is the benefit of using a band ratio. Okay, so yeah, please ask me more questions. Feel free to ask me more questions.
Uh, but will that not be make both the images having less features, as sunlit has more digital number, that is 48, and with the shadow it has 18. But as we are taking ratios, this feature will not get excluded as uh, to feature extraction if we are doing, or the same features we will get after ratios, after counting the ratio as well.
Yeah, see, this is a fantastic question. It's a fantastic question. See, there will be no change in the amount of variations. Okay, how do we understand that? So if you look at a deciduous tree and the coniferous tree, the example that is given here, see, after band ratioing, they are falling at different percentages, right? Different ratios, we can say, not percentage fractions, we can say, or ratios, we can say, or different decimal values, we can say. So it is clearly found out that the one for deciduous will not be same as the one for coniferous, and it will be different for all the different features present in an image. Okay, so there will be no loss of variation, but the benefit will be we will get an image where we have uh, proper representation without the biasness of the external conditions. Is it clear, Nishiganda?
Yeah, yes, sir. Yeah,
Okay,
thank
yeah,
you.
fantastic. Any more doubts, please let me know. Any more doubts, please let me know.
Good evening, sir.
Good evening, Raj.
Sir, actually, the example you gave, actually, there is a feature. The example you gave is a mountainous feature and the forests on it.
Yes.
So, I want to ask that is it applicable on every type of feature, or just on these kind of features where these external environmental things come in between? Okay.
Okay, so I would like to answer it in this way. See, suppose we have a satellite image and we want to do this thing. So there has to be a purpose why we want to do it. Okay, And what is that
Yes.
purpose? So if we have an image which is taken in a hilly region, and we find out that some portions of the hilly region which is at the sun shadow side are having some disparity, and it is difficult to find out, then only we will try to use techniques of ratioing. So it is not necessary to do ratioing to every images. Suppose I take an image in the regions of West Bengal or Bihar where most of the land is a flat land, then there is no need of ratioing. But if we take this same image into in the plains of Kashmir, Uttarakhand, they or Himachal Pradesh, then we need to go into ratioing. Moreover, ratioing is important when we are working with good resolution data, because usually if we have low resolution data, that means we have taken an image of a larger area kept into a smaller frame. In those cases this is not that much evident, but as we go up with higher resolution data, this becomes more important to consider. I hope that answers your question, Raj.
Yes, sir. But the conclusion what I get is that the ratio depends on the area we are working on and the resolution of it.
Not exactly, not exactly. uh, it is we can put it in this way, that it is more important when we have a high resolution data, because in that case the sunlit and sun shadow portions are more prominent, and it becomes more important to differentiate them. So I can put it in this way. Other than that, we will use this technique only when it is necessary, not in every case.
Okay, so thank you.
Yeah. Any more questions, please? Yeah. So if there is no more question, so the session will end here. So next day, please read the next four videos starting from the eighth video. So the next four videos will be 1, 2, 3, 4, 5, 6, 7, 8. So yeah, these four videos up to image processing hands-on demo using QGIS. Please read up to this one, and feel free to come with your doubts. I'll be happy to help you. Next class is on next Saturday. Yeah, Aditya, next class is on next Saturday. I'll be here every Saturday. If there is any issue, like today we had a lot of issue while joining, the network was not working properly. So I joined 5 6 minutes late. I tried joining, but it didn't happen. So if it is a situation like that, we can then of course take some more time to join. Or if there is some problem like I couldn't do the class anyhow, then you will get a message in the announcement section that the class will not be happening on that date. Other than that, we will be having class every Saturday from 6:30 p.m. to 7:30 p.m. and I'll be happy to help you with your doubts. Oh, I hope that is clear. Is it clear, all of you? Please. Yeah, thank you. Yeah, thank.
Uh,
Yeah,
okay,
yeah,
sir, may
Shivani.
I ask you one question? Sir,
Yeah.
where can I get your information? Okay.
Which information can you please tell me?
Like you have told earlier, कि I will update you कि class will happen or not.
Yeah, see, you have this announcement page, right?
Okay, sure,
So
sir. Okay.
yeah, so I'll try to put things in announcement page if something happens suddenly. But if it is like this, that what happened today, that there was problem in joining, this won't be announced there. Is it clear?
Okay. Okay, sir. Thank you so much, sir.
Yeah, thank you so much. Okay, sir, when will the unit 1 exam be held? Yeah, Pashin, many people have the same question. I forwarded the question to the authorities. I'll let you know when they reply. Before that, I cannot say anything from my own. Yeah, so today's session was extremely interactive. I enjoyed the questions, and thanks for asking the questions. Yeah, so bye bye, all of you.
Okay, good night, sir.
Good night.
Thank you, sir.
Yeah, bye
Thank
bye.
you, sir.
Okay. Yeah, bye bye. Bye bye. Bye bye. Thank you.
Thank you, sir.
Okay.